Functions in trigonometry, final exam, study guide, review. This is video number 3. Let's pick up with problem number 16. 3 raised to the x plus 8 equals 2. Now how are we going to solve this? Well, this is what we use logarithms for. My first move is I'm going to take the logarithm of each side. Now you can use log base 10. You actually can use log base anything. I'm using the natural log because the problem asked me to. It says express the solution set in terms of the natural logarithm. So I'm going to use the natural log. Okay, and this is why we do this, is if I take the natural log of both sides by the power rule, this exponent now becomes a coefficient. And now that it's a coefficient, I can divide both sides by natural log of 3. So I get this expression and then subtract 8 from each side, and then I'm done. All right, but the key to the problem is taking the natural log. This then is moved down as a coefficient by the power rule. Okay. Number 17, convert degrees to radians. Okay, this is a gimme. This is convert 160 degrees into radians. I just put it in my formula. Degrees to 180 is equal to radians to pi. Cross multiply, solving for radians, reduce. Okay, that's a gimme problem. Okay, and another cofunction problem. And it says, what is the cofunction of tangent 7? Well, I know that the cofunction of tangent is cotangent. And then I need to take the complementary angle. And this is the definition of cofunctions. The tangent of 70 degrees is equal to the cotangent of 83 degrees. Some of our other cofunctions is, I could say, the sine of 70 degrees is equal to the cosine of 83 degrees. Why can I say that? Because sine and cosine are cofunctions. All right, so make sure that you have your cofunction sets memorized. Okay, trigonometric applications. The biggest thing that we have to do here is from the words of the problem, you need to visualize the triangle, the right triangle. The words of the problem are describing a right triangle to you. And a right triangle can be solved with trigonometry. All right, so if you read the words of the problem, and I strongly suggest you set up a diagram, and if you do that, you understand what they're asking for. This guy wire for the tower turns out to be the hypotenuse of a right triangle. And I'm given these other dimensions, or can figure out the other dimensions. I've given an angle from all the information. If I take the 220 minus the 14, that gives me a side opposite. So I can solve for the hypotenuse using the sine function. A little bit of algebra. Final answer. Number 20. The exact same type of problem, really. The key is I need to visualize a right triangle from the information given. Some of the hints is a lot of the problems, they say how tall something is. And you can almost bet your bottom dollar that's going to be at least part of a side opposite, or maybe the side opposite itself. All right, here my side opposite, the building is 270, but the person is 6 feet. All right, so I need to take the 270 minus the 6 feet to get this side opposite of this triangle. All right, and then this is the angle theta that I'm solving for. This side adjacent is going to be the same as this length of this shadow. All right, and so I know an opposite, I know an adjacent, so to get the theta, I chose to use the tangent function. All right, and I got a ratio, and then the inverse, or the arctangent, I got then my degrees as being 69.3. Okay, on 21, Again, the secret is let's set up the triangle. The given information will make a right triangle. You might say, well, my given information here is an ordered pair. So the first thing I do is I plot the 4, -3. You're taught how to plot that in 4th grade. All right, well, how does that make a right triangle? Well, the x-coordinate becomes a side adjacent. The y-coordinate becomes a side opposite. By the way, these signs are important. All right, this is in 4th quadrant, so smart trig class. So cosine here is going to be the only positive trig function that I have. How do I get this 5? Just Pythagorean theorem. I know these two sides. Pythagorean theorem gives me the hypotenuse. It's asking me for the sine of the angle. It's not asking me for the angle. It's asking me for the sine of the angle. You need to understand, I'm asking two different things if I ask that. If I say, what is the sine? Said, well, the sine is the ratio of the side opposite over the hypotenuse. If it was asking for the angle, then I need to take the arc sine of this. Notice the negative sign because sine is negative in the 4th quadrant. However, if you've drawn this correctly and you say, well, that 3 is negative, then this negative here is going to happen automatically for you. Okay, number 22. Okay, it's asking for a reference angle. Right? Reference angle is different than a coterminal angle. There's lots of different ways to figure it out, but you have to understand what reference angle means. It means what is my angle to the x-axis. Doesn't matter if I'm below it, above it, negative x-axis, positive x-axis, doesn't matter. What is my angle to the x-axis? All right, well, the angle they give us is 17 pi over 3. Well, look at your unit circles, or what I've done. I've kind of done a little sketch here, and I have drawn basically 1/3 pies, right, which happens to be 60 degrees. Right, so 60, 120, 180, so on and so forth. In radians, there's 1/3 pi, 2/3 pi, 3/3 pi, 4/3 pi, 5/3 pi, 6/3 pi. I've gone around the circle. That is 2 pi. All right, so if I go around again, that's 12 pi. If I go around again, that's 18 pi. It's one too many. So let's go around the circle twice. 12, 13, 14, 15, 16, 17. All right, so this line right here is going to be my angle because 5 pi over 3 is coterminal with 17 pi over 3 given in the problem. Okay, so this angle, what is this angle? Right, this angle is in reference to the positive x-axis. That's my reference angle, so it's pi over 3. All right, let's look at problem number 23. Okay, this is just transformations of sine, cosine, and tangent functions. We know this lead coefficient, its absolute value is the amplitude. We know that this